Hi, this is Vincent Corporation, Plant Works Group. We have here a Siemens S7 control panel. We're using for a dual press system. We're supplying to a customer. Just going to walk you through some of the automation that we're doing here. And we'll start by opening up the control panel. You get a good look at the PLC we got in there. That's the brains of the control panel and what's going to be used to control the machinery. So how we do our controls is separated into two compartments. We have a high voltage cabinet isolated with a low voltage cabinet. All of 480 three-phase takes place in here. We have two motors that we're controlling, 230 horsepower. We have these disconnects that are located on the outside of the panel for safety, so you can shut off the motor manually if you want to without having to go inside the panel, or your operators don't have to get exposed to the high voltage. So this is a single circuit control panel. Everything links back to the main breaker here. We're running a 120 by 480 transformer at the bottom of this cabinet. That's on. We transform our 120 goes up to our 24 volt power supplies. We're using a UPS to back up the PLC. So if you were to have interrupted power supply, or if this main breaker would drop out, the PLC will continue to run, continue to collect the data, and let you know that there's a problem going on in the lower cabinet. Let's go ahead and power things up. So what we're doing here is we have a two-press system where one press is an overflow for the other. So we have some level control mechanisms that we're using to control the motor speeds. And to gauge what is going on inside the level of the hopper, we're using these devices here. They're Banner radar sensors. It's a new type of technology, better than ultrasonic and other types of sensors because you can see through steam, other gases and things that get in the way of nominal level sensors that have been used before in the past. So the screen's probably powered up at this point. We can go ahead and run our application. And we're doing a few things here. This application is going to be for municipal waste. So with municipal waste, we want to make sure that we have an auto reverse feature in there. So it'll control how many seconds the press runs forward and how many seconds the press runs backwards to prevent any jamming. See right there, UPS is activated, the main breaker has been disconnected, so it's letting you know that the battery is taking into effect, and we have our PLC still powered up even though the main breaker is on. So we have forward, reverse, stop, manual controls for each one of these presses. We're also controlling all the actuators and all the pneumatics associated with these machines. We're controlling the cone pressure and the cone position. We have some feedback that is provided by these two instruments here, two I to P transducers that we're using to control the cone and let us know how much pressure we actually have at the unit itself in the field. So going back to the screen now, we have our level sensor options. There's a manual and an auto you can run it in. We're showing it in manual right now. Let's go ahead and switch that over to auto. So if the level gets high, this hertz will jump up to a higher frequency to try and clear that level out. And how often and what speed that the press jumps up in speed is controlled by our tuning page, where we have how much time has to pass while the level's high in order for it to jump up, and when the alarm needs to sound as well. So we have that for each one of our presses, and we have feedback for all of our motors. We have our amperage being displayed there for each one of the motors, and we also have a direction, a run, a trip feedback, and some other safety interlocks that go along with these two pieces of equipment. We're taking another look inside. We're using Ethernet to connect everything. This PLC is going to be hooked into a historian where it's going to be constantly sending tag data over to the plant PLC for confirmation and for their own data analysis of their plant running as time goes on. So quite a unique little system. We usually don't incorporate Ethernet, but we have it here. No problem. We're using Profinet to communicate over. And these are all of our actuator controls. Our field connectors are pre-wired, so the electrician, when he gets out in the field, knows exactly how to reconnect it to minimize any downtime that's going to go along with hookup. And that's our control system that we have here, ready to get shipped to a customer.